Hello and welcome. This video is the first in a series designed to help you understand data in your automation projects. Today, we are focusing on the absolute fundamentals, basic data types. Before we look at the different types, let's answer a simple question. What is a data type? Think of it as a label for a box. This label tells the system and you exactly what kind of information is allowed to be stored inside that box. Can it hold a whole number, a number with a decimal point, or maybe just a simple on or off status? The data type defines these rules. In your programming environment, every single variable you create is defined by two essential things. First, its data type, which is what kind of information it holds. Second, its address, which is where it is stored in the PLC's memory. Let's explore both of these ideas, starting with the most common data types. Part 1, the most common data types, the what. We will group these into a few simple categories. Category 1, on or off, Boolean. The simplest data type is called a Boolean, or just Bool. A Boolean variable can only have two values, true or false. You will use this all the time. Think of it as on or off, open or closed, running or stopped. It's the most basic building block. Category 2, whole numbers, integers. Next, we have integers. These are for storing whole numbers with no decimal points. Because different numbers can be small or very large, there are different sizes of integers. You will commonly see int, which stands for integer, and DInt, which stands for double integer. The DInt can just hold a much larger number than an int. You will also see variations like SInt, short integer, or lint, long integer, which is a 64-bit number for extremely large values. You might also see a U in front, like UInt or UDInt. The U stands for unsigned. An unsigned integer cannot be negative. It only holds positive numbers. The benefit is that it can hold a positive number that is twice as large as its signed counterpart. My recommendation, if you know you will never need a negative value, use an unsigned integer. Category 3. Decimal numbers, floating point. What if you need to store a number with a decimal point like 73.5? For this, you use a data type called a real. This is also known as a floating point number. This is what you use for precise measurements like temperature, pressure, or positions. Category 4, text, characters, and strings. Sometimes you need to store text. A char is a single character, like the letter A or the number 5. A string is a sequence of characters, like a word or a sentence. This is useful for storing messages, product names, or recipes. You may also see a wchar or wstring, which are wide versions that can store a larger variety of symbols from different languages. Category 5, time and dates. Your PLC also has special data types for handling time. Time. This is used for storing a duration, like 5 minutes or 100 milliseconds. Time of day, or TUD. This stores a specific time on the clock, like 2:30 p.m. Date. This stores a calendar date and time, or DTL. This stores both the date and the time together in one variable. You might also see LTime, which is a 64-bit long time for storing very long durations with high precision. Category 6, raw data, byte, word, DWord. Finally, you will see types like byte, word, and double word. A byte is a collection of 8 bits, 8 on or off signals. A word is 2 bytes. A double word is 4 bytes. Think of these as raw, uninterpreted data. They are very useful when you just want to look at the raw binary ones and zeros from a device without the system trying to interpret it as an integer or a character. The where. Now that we know what data we are storing, we need to know where it is stored. This where is the variable's memory address. Think of the PLC's memory as a big set of mailboxes. We need to tell the variable which mailbox it lives in. This address typically has two parts, the memory area and the location. The memory area is usually a letter like I for inputs, Q for outputs, or M for internal memory. The location is a number that points to the specific spot. The data type you choose determines how much space that variable takes up. A bool takes just 1 bit. Its address might look like M0.0. A byte takes 8 bits. Its address would be MB1 for memory byte 1. A word takes 2 bytes. Its address would be MW2 for memory word 2. A double word takes 4 bytes. Its address would be MD4 for memory double 4. Notice how the address letter changes? M for bit, MB for byte, MW for word, and MD for double word. This tells the system how much space to grab, starting at that location. How to find information. This can feel like a lot to remember, but here's the most important. You don't have to remember it all. If you are ever in your programming software and are unsure what a data type is or what its range is, you can almost always use the help function. Just click on the data type you're curious about and press the F1 key. This will open a detailed description. You can also usually hover your mouse over a variable, and a small pop-up window or tooltip will appear. This tooltip will tell you the variable's data type and its memory address. This is incredibly helpful for troubleshooting. Conclusion and next steps. So, to review, we learned that all variables have a data type, the what, and an address, the where. We covered the basic types, like Booleans, integers, reals, and time formats. These basic types are the building blocks for everything else. In the next video, we will build on this knowledge. We'll explore structured data types or user-defined types, UITs. This is where you can combine these basic types to create your own custom data type, which is an extremely powerful and organized way to program. Thank you for watching. If this video was helpful, please leave a like and subscribe for more content. If you have any questions, feel free to leave a comment below. See you in the next video.